Good morning, ladies and gentlemen. Welcome to Team Calabash's presentation of the just-in-time pool system implementation at Mac Brothers Catering Equipment. Just to give you a little bit of a rundown of what we're going to be covering in the presentation today, we're first going to do a bit of an introduction to Mac Brothers, then we'll move on to the results achieved through the proposed implementation. Erald will then be taking you through 4 steps of a gap analysis that we are going to cover. We'll then look at application, some further considerations, key learnings, and finally end off with a summary. Mac Brothers Catering Equipment was established in 2002. The company has manufacturing facilities in Epping, Cape Town, where they manufacture an extensive range of catering and refrigeration equipment. The major customers of the company include the Spur Group, Burger King, Cape Town Fish Market, and many other hotels, corporate canteens, supermarkets, wine farms, and government institutions. The company is currently experiencing production problems in the refrigeration department, and the focus of this proposal is the implementation of a pool system in this department in order to improve on the business processes. The key focus is to improve process time and minimize waste during the production process in the refrigeration department. Just to provide a little bit of context to the problem, we wanted to show you a brief diagram of the area that we're going to be focusing on in our presentation. As you can see here, indicated by the red rectangle, this is the area where the refrigeration units are produced, and this will be the main focus of our presentation today. Just before we get into the nitty-gritty of the proposed project implementation, we'd just like to start off by sharing some of the proposed benefits that we envisage after the implementation has been successfully completed. A few of these include reduction in work stages from 10 to 6, a labor cost saving of approximately 65,000 Rand per annum, additional floor space which will be made available as a result of process flow redesign, saving approximately 40,000 Rand per annum, in-process inventory, work in progress, reduced from 16 to 25 fridges, which is the current average, down to a maximum of 12. Reduction of work in progress inventory as well as lead time of between 25 and 52% dependent on stage, reduced walking and transport time between processes, and a total return on investment in year 1 of approximately 87,000 Rand. This is the benefits less the costs of implementation and improved staff morale.
So the big question now is, how did we get to these proposed benefits? In the next few slides I'll be elaborating on this. The whole process was managed under a gap analysis, or that is also known as the as-is versus to-be analysis. Step 1 of the gap analysis is to construct your organizational goals. So under the purpose and value statement of Mac Brothers, in the sustainability section, we find a line reading the application of innovative and lean business practices. This together with the 5 performance objectives in ops management set our strategy in place. Our aim was to increase the time and flexibility areas of the process and in that way lengthen the string. The second step in the gap analysis, the as-is state, is to capture the current condition. We did this by doing a floor layout in 2D CAD and a process step sheet. Just to show you quickly, this is the current floor layout. If I zoom in, you can see stage A, B, C, D, and the amount of pink lines showing the cross flow within the process. Also note the distances between the stages, which indicates high wastage in transportation, waiting and walking. Secondly, we captured all the steps in the manufacturing process in the current condition and grouped them by stages. You can see the grouping of the stages on the right hand side. The second tool we used to capture the current state was the process of identification of the 7 wastes of lean. In these pictures you can clearly see overproduction and high in-process inventory or work in progress on the factory shop floor. The third tool used in the gap analysis capturing of the current state was fishbone diagrams done at process level for each stage. The bones of the fishbones considered was man, machine, method, material, and environment. The most commonly found inefficiencies was high levels of work in progress that caused clutter in the work area, Poor scheduling and incomplete bill of materials. That means that the manufacturing unit was started without all the raw material and components available to produce the unit. The third step in the gap analysis is to define the ideal condition, or the 2B case. Two goals was defined for Mac Brothers. First being to design a production line that strives to zero waste by eliminating 7 areas of waste being overproduction, overprocessing, defects, inventory, motion, waiting and transport. The second goal was to implement the just-in-time system that characterizes a pull system, as only the required quantity of each part is produced in the manufacturing and production process. To illustrate just-in-time, I'm going to play you a short video. In this video, it's important to notice this time saving on the right hand side and also the floor space required for each of the manufacturing processes, indicating a batch size of 10, 5 and 1. The last step in the gap analysis is to look at your as-is and to-be conditions and identify and document the gap. The gaps we identified is that the process flow must be improved in order to minimize the waste of motion, waiting and transport. We need to strive towards a design that uses optimal floor space, reduce in-process inventory by stretching the stages of assembly as far as possible. We need to improve the communication in the assembly stages by using a Kanban process, and decrease the lead time by reducing waiting time between the different stages, and this in return will decrease the total production time and increase flexibility in production. Numerous advantages and improvements came from the application and design process, but I'm just going to take you through 4 of the highlights for the sake of time, them being the current versus proposed floor layout, new activity sheet, the trolley design for one-piece workflow and the inline grinding bay. Looking again at the as-is versus to-be floor layout, in the as-is we can clearly see the cross flow distance between stages. In the proposed flow we have a U-shaped flow with no cross flows and wastage in terms of that. We have saved this whole bottom corner here in terms of floor space that is now being used by another department. And this whole area here is a picking area that can be used to increase the bomb accuracy before the unit is put into production. Looking at the step sheets of the as-is versus to-be, initially we had 10 stages in the production process, and by combining those stages and stretching the process as far as possible, we could reduce that down to 6 stages. Another activity we looked at is the design of a trolley that would complement the one-piece workflow through the process. 3 concepts was generated, and the one on the left hand side was selected because it occupies the least amount of floor space and accommodates all shapes and parts required in the manufacturing process. Another key improvement for us was the installation of a mini grinding bay in one of the sub-assembly processes. This suggestion actually came through collaboration with the supervisors and team leaders of the work area that identified to us that this might be a requirement. In an as-is condition, worktops and various parts must flow to a grinding bay that's at least about 100 meters away from this process. So what we did is we designed a mini in-situ cell grinding bay that eliminates the walking and transportation associated with this process. We believe this to be a key improvement in the manufacturing process.
First, we'll have a look at the key elements to take in consideration before implementing the new process. The lack of education and training amongst our staff members would be key to the success of the new process. The new process will require a multi-skilled staff member to operate on certain levels of the process. Possible bottlenecks have not been identified. Thus, we will have a constant monitoring to determine where bottlenecks can occur. The just-in-time system can come to a standstill if one of the critical stations are not in operation. Thus again, regular maintenance of our key equipment would be crucial to the success of the process. Key learnings. As a team, we should have involved the key staff members much earlier in the process, as they had valuable inputs. Without the buy-in from the staff members, change management will be difficult to implement successfully. Special attention needs to be given to the bottleneck stations to ensure continuous workflow. Flexibility and efficiency is greatly improved upon the just-in-time pull system. The pull system works well as long as the support structures are well in place. For example, there is no backup stock to buffer against unforeseen events and mistakes.